Today, we're diving into SAP HANA. Now, if you've heard anything about it, you've probably heard this one thing. It is unbelievably fast. And that speed comes from its whole design as an in-memory database, which means it does all its work right there in super fast RAM. But, that one single design choice immediately brings up a huge question. So let's really think about this for a second. We all know that RAM, main memory, is volatile. That's just a fancy way of saying that if you restart your computer or the power goes out, everything in it, well, it just vanishes. So how can a database, something you trust with your absolute most critical information, live in such a temporary home? It feels like a massive, crazy risk, right? Well, the solution to this paradox, it doesn't come from some external backup system. It actually starts right inside the RAM itself. You see, SAP's engineers didn't just throw data into memory and hope for the best. They built this really clever internal structure, splitting the RAM into two very specialized zones. Each one has a totally different job. The best way to think about it is like a front line and a fortress. The Delta storage, that's your front line. It's dynamic, it's constantly changing, and it's built for the high-speed chaos of both reading and writing data. This is where all the new stuff happens. But then, behind it, you've got the main storage, the fortress. This area is totally optimized for reading and for compressing data. It's built to hold the final, confirmed version of everything, nice and secure. Okay, so how does data get from that chaotic front line into the secure fortress? That is where our first key process comes into play, the delta merge. The source material actually uses a perfect analogy for this. It says you can't just attack the main villain, in this case, that big compressed main data store. It's just too costly to change because it's already so perfectly organized. So just like in a good movie, you've got to go through the subordinates first. And that subordinate, that's the delta storage. So let's follow the journey of a single transaction. Let's say you're booking a ticket or placing an order. All that work, all the queries and calculations, it all happens in that quick, nimble delta storage. But only once that transaction is officially committed, meaning it's final, it's done, only then is the result moved into that highly organized main storage. And that whole process, that movement, it has a name. It's called the delta merge. It's just the system merging the recent changes from that temporary delta area into the main data fortress. It's basically the internal housekeeping that keeps the entire database running smoothly and efficiently. And this is where we see a huge payoff of this two-part system. The moment that data hits the main storage fortress, HANA works its magic and compresses it, sometimes making it up to 10 times smaller. This is absolutely critical because RAM is expensive, and squeezing the data down means you can fit way more information into the same amount of physical memory. Okay, so we've got the organization problem solved. Inside our RAM, our data is tidy, it's compressed, it's efficient. But this only solves half the problem, doesn't it? We still haven't actually dealt with our original fear. All of this is still just sitting in volatile memory. What on earth happens when the power cord gets pulled? And this brings us to the second and arguably most important piece of HANA's safety net. This is the process that builds the bridge between temporary memory and permanent storage. It's called the save point. And the most important thing you need to know about the save point is this number right here, 5 minutes. Every 5 minutes, like absolute clockwork, the system does something essential for survival. The save point is this automatic process that takes a complete snapshot of everything inside the main storage, our secure data fortress, and it writes it from that fragile, volatile RAM to a permanent data folder on the physical disk. This is it. This is the bridge from the temporary world of memory to the permanent world of storage. So now that we have both the delta merge organizing things internally and the save point making them permanent, let's see what actually happens when we restart the system. This is the ultimate test, right? All right, so here's our system humming along. The HANA database is actively using about 13 gigabytes of RAM. That's our data. It's alive in memory. It's powering our applications. Everything's great. And now we shut the database down. Whoa, look at that drop. RAM usage just plummeted down to 6 gigabytes. That 7 gigabyte difference, that was our data. And it has just been wiped clean from volatile memory, exactly what we were afraid of. But is it gone for good? No way. When we start the system back up, this is where the magic happens. The main memory, it's completely empty at first, but the system immediately knows to look for that permanent data folder on the disk, where our last save point was stored. It then reloads that entire data snapshot from the disk right back into RAM. And just like that, the database is back online, fully operational, with absolutely zero data loss. And that is the whole secret. Even though all the day-to-day work is happening in that lightning-fast temporary memory, the SavePoint process guarantees that a complete, persistent copy of your data is always safe and sound on the disk, ready to be reloaded the second it's needed. So, let's put it all together. It's this really elegant two-part solution. Inside the RAM, you have the Delta Merge acting as the super efficient organizer. And then you have the SavePoint acting as the insurance policy, writing all that organized data to a permanent disk. Together, these two processes completely solve that in-memory paradox, giving you both incredible speed and total data safety. And that really brings us to the final thought. We started this whole conversation with the fear that in-memory speed was just too risky. But now that we see how incredibly well the data is protected, it makes you wonder, right? What new doors open up when you can analyze massive amounts of data in real time with complete and total confidence that it's always safe? Now that's something to think about.